Hey everyone, welcome to DevFest. If you're in the Flutter world, you know state management is a huge topic. For a long time, Riverpod has been a go-to solution for many of us. But there's a new player gaining a lot of traction, Signals. In this video, I'm going to walk you through a migration I did on my Taekwondo app. We'll look at how I was managing state with Riverpod, and then see how I converted that same logic to use the Signals package. The goal isn't to say one is better than the other, but to show you the differences in syntax, the mental model, and what the migration process actually looks like. We'll compare the original Riverpod code side by side with the new Signals code. We'll focus on setting up simple signals and computed signals. So here's how the points tracker worked with Riverpod. Riverpod is based on the concept of providers, objects that provide a piece of state to our app. For simple providers like the following, I used annotations to build the provider. This requires running dart run build runner build. You then use it like this. First, I define my learned points notifier. The build method sets the initial state, a set containing the first form. Then I have methods like add points and remove points. Notice how they update the state. They create a new set. This immutability is key to how Riverpod detects changes. Now, here's how the widget would listen to this and display it. Inside my consumer widget, I use ref.watch to listen to both the master list and the state of our notifier. When ref.watch is called, Riverpod knows this widget depends on that state. When the state changes, because we created a new set, Riverpod rebuilds this widget. To change the state, I use ref.read with notifier and then call my add points method. Ref.read is for doing something without listening for changes. So the flow is a widget, which calls notifier method, the notifier creates a new state, and ref.watch detects this new state, and the widget rebuilds. This Riverpod code works perfectly fine. It's robust and testable. So why look at Signals? Signals offers a different mental model. Instead of rebuilding entire widgets, Signals allows for fine-grained reactivity. The idea is that only the exact part of the widget tree that depends on the signal will update, often without calling set state or rebuilding the whole widget. So what are some of the potential benefits? One, there's simpler syntax, often less boilerplate, no need for separate notifier classes for simple state, and performance. It can be more performant because it avoids unnecessary widget rebuilds. If you've used React or Solid.js, it feels very similar. State changes push updates rather than widgets pulling them. Okay, so here's the exact same logic rewritten with Signals. With Signals, you just create a signal. Instead of a notifier class, I can often just define my signals. I like to put them in a simple class or just as globals, similar to providers. That's it. No special classes, no build methods. All points is a signal holding my list. Learn points is a set signal, which is optimized for sets. The state itself is a signal. To get the value, you access .value. To change it, you set .value or use methods like .add on the signal. Notice this computed signal. Learn points count will automatically update only when the learn points signal changes. We don't have to manage this dependency, the system figures it out. Now, let's look at the widget. This is where it gets really interesting. First, my widget is just a stateless widget, no consumer widget anymore. Inside the list view builder, I'm wrapping my list tile in a signal builder. The signal builder automatically subscribes to any signal that is read inside of it. In this case, learn points.contains. When I click the checkbox, I call learn points.add or remove. This mutates the signal. The signal then notifies all its listeners. The only thing that rebuilds is the inside of that specific signal builder for that specific list tile. The list view itself doesn't rebuild. The points list view widget doesn't rebuild, just that one checked box in title. If I did need the whole widget to rebuild, I could just call learnpoints.watch context at the top of the build method. It's similar to ref.watch. The big shift is from immutable state plus widget rebuilds, which is Riverpod, to mutable state plus fine-grained listeners, which is signals. The business logic in Riverpod lives in the notifier and signals that can live right in the widget's event handler or in a separate controller class that mutates the signals. So we saw how to take a Riverpod notifier that managed a set of learn points and convert it to a set signal. We changed our consumer widget with ref.watch to a stateless widget with a signal builder. It felt very direct. The code in the widget is simpler to read. On changes the state. Done. The performance aspect is real appealing, especially for this list. Only the row that changed gets updated. Less boilerplate. I didn't need a whole separate class just to manage a set of strings. It's a very different mental model. You have to unlearn the everything is immutable rule from Riverpod and provider. It can be tempting to put too much logic directly in the widget. You still need to be disciplined and extract complex logic into separate functions or classes. Riverpod has a huge, mature ecosystem with features like .family, async notifier, and opdispose, which are incredibly powerful. Signals is newer, so the patterns are still emerging. For my Taekwondo app, I'm really liking Signals for this kind of UI state. It feels fast and simple. But for complex business logic or data fetching, Riverpod's async notifier is still an amazing tool. The good news, you can use both in the same app. What do you think? Have you tried Signals? Are you sticking with Riverpod? Let me know your thoughts in the comments. Thanks for watching and keep training.